Bismillahirrahmanirrahim. In the last class, we saw how to use case. How to use case for designing a 7-segment display. Right? Today, inshallah, we will finish this chapter. First thing we will see is how to write don't care. How to write don't care using Verilog. Remember don't care? That we represented in table by x. By x. So don't care means it can be 0, it can be 1. It does not matter. You can take it 0 or you can take it 1. Now remember priority encoder or priority encoder. Remember? What? Priority that we had. Right. This like what was it? Say A3, A2, A1, A0, Y. There was Y3, Y2, like this. Remember? Y1, Y0. And we saw that if A3 is 1, all are don't care. This is 1. And all 0, right? Now if this is 0 but this is 1, then these two are don't care. So output is like this. So this is highest priority. If A3 is 1, all of them are don't care. And output Y3 will be 1. Now if A3 is 0, then if A2 is 1, these two are don't care. Right? Like this. So this was priority encoder. So if we want to solve this one using Verilog, so what we can do is we can use something called case Z. Okay, this it was case here. Okay, but this one is case Z. It is using this don't care. It allows using don't care. Okay. Yes, you can say. So here you have module priority case Z, the name. Input is 4 bits. Like 4 bits. Okay. And output like 4 bits. Okay. And this should be written as output red because Y is on the left side of assignment, inside always. Inside always. So here you write always at star means for all condition case ZA. So based on the value of A, you will have an output. Okay. So now the value can be 4 types. Like here. These are the 4 types. 0, 0, 1, X, 0, 0, 0, 1. These are the 4 types. That if this is 1, all of them are don't care. If this is 0 and this is 1, these two don't care. These two are 0, A1 is 1, this is don't care. All of them 0, this is 1. These are the 4 types of inputs. 4 types of inputs. Okay, so here you have, this is which one? The first one, see?
Yes.
If A is 4 bits, binary, and this A3 is 1, and all of them are don't care, by a question mark. This here, this question mark means don't care. Okay. So if the first bit is 1, but all other are don't care, what should be the output? 1, 0, 0, 0. So Y assign the value 4 bit binary and the value is 1, 0, 0, 0. And about this one, value is 0, 1, don't care. Third one is 0, 0, 1, don't care. Fourth one is 0, 0, 0, 0, 0, 0, 1. Okay. And if you give any other value, the default is if you give any other value, output is all 0. All 0. Okay, because you don't have these values. So output is all 0. So this is how you can make a priority encoder. Priority encoder. The digital circuit we saw in chapter number 2. In chapter 2, if you go back to your slides, you will find this priority encoder. This table, you will find it.
Like, for example.
Yes, yes. This is the Verilog version, and that was the digital logic by hand. We designed by hand, and this is if you do by this program. If you do by programming.
In case, before slide, where are in case?
Yes, yes. If you start with case, you should end with end case. Okay. Like end module. The module, end module. Case, end case. But for always, there is no end always.
Nothing.
Nothing. But if you have more than one line, we showed you here. If you have more than one line, you should write begin, end. Here, see, for always, there is no say end always. Nothing like this. So how you know you finished always, right?
Yes.
How you know you finished always. So what we do is, if you have say only one line, no problem. Under always only one line, no problem. But if you have more than one line, you put begin, end. Between begin and end, you write your.
In case not begin.
In case there is no begin, then the program will assume that only this line is with always. You understand? You understand? It is like in C. In C, if you write if, and then if you write one line, then this one line is with this if. But if you write two lines, then you need to put brackets. You need to put brackets. But if you don't put brackets by mistake, then first line is with if, and the second line is outside if. Outside if. Do you understand? So if you want to put the both line with if, then you need to put bracket. Here, same thing. If you want to put all the lines with always, here you don't have brackets, you have begin, end. Do you understand? Same thing, same concept, but different language does in different ways.
But in case?
In case, for case, you have case and case. So between them is everything you have. Huh? For case, you have and case. You understand? This and case is with case. So from case to end case, everything is inside the case. Okay. So I told you before that we have three types of assignments. Now you see all of them together in summary. We saw that you can use this one, you can use this, and you can use assign. As like Y, B, B. These are the three ways we saw the assignment. These three ways, see? Here, this way. Okay, this way. This one.
Second way.
This one, this second way. This one. And assign. this third row assigned. Okay, so we have three ways of assignment. What is the difference? What is the difference? This is what we will see, inshallah. The difference is between these two, the main thing to understand. Okay, these two. The difference between them is important. Say I have y equals, say b, y1 equal to b1, y2 gets b2, and say y1 b2. Okay, say I write these two lines. So what is the difference between these two lines and these two lines? Okay, y1 will get b1 and y2 will get b2. Here also y1 will get b1, y2 will get b2. This is clear, same thing. But this one is called blocking. Blocking means after this line is finished, this line will execute, or this line will carry out. You understand? This is called blocking. It is like you have one road where only one car can go. Do you understand? So this one will first go, then after that this line will go. Okay, this is called blocking. Block. After it blocks the way of this, right? If you have a car here and they are going this way, if this one is blocking the way of this, right? The first car will block the way of second car. That's why it is called blocking. Block. So if behind coming, wait, he has to wait. This one finish, then this one will execute. For this one, it is like you have one road but two lanes. So your car is here. Also, your car is here. Two cars like this. So in general, if you have this assignment, then not all. If you have this one, then it will be assigned one by one. You understand? First line, second line, like this. But if you have this assignment, all the assignment will be done at the same time. All of them will be done or will be carried out at the same time. Okay, so this is called blocking, and this one is called non-blocking. Non-blocking means not blocking. It is not blocking. Non-blocking. Okay, so for this case occurs simultaneously. Simultaneously means at the same time. The word simultaneously means at the same time with others. But in this case, in the order it appears in the file, in the order, one by one. Okay. For example, here you can see this is the sample code. Module synchronizer good, and it is synchronizer bad. Okay. So it's taking input clock, input D, output Q. So it's saying these two lines. Let's just see these two lines. These two lines means this is non-blocking. Non-blocking. So N1 and Q will get the value or execute at the same time. But for this line will first finish, and then this line will finish. And see the different code, different circuit for these two. See, they from this one and this one. See, the only difference is here you have non-blocking assignment and here you have blocking, right? in this code and in this code, where is the change? Where is the difference? Difference is only here, see? Only here. Only difference. No more difference. Huh? But see the different circuits. For non-blocking case, you have this circuit. But the blocking case, you have this circuit. See, in the non-blocking case, you have for this assignment with the positive edge. This is actually a D flip-flop, right? With the positive edge, the output gets the input. It's a D flip-flop. The D flip-flop is what? With the edge, the positive edge, the input will go to the output. This is D flip-flop. So for this example, see, you have two D flip-flop. One D flip-flop is this one, another one is this one, and they are both getting the same clock. That means with the same clock edge, the two flip-flop will work at the same time, right? They will work at the same time. That's why it is called non-blocking. But for this case, the second line cannot finish before the first line. Okay, so here you can see you have only one D flip-flop, and there is a change inside. There should be a change inside how you get this assignment. Okay, so actually what it is doing is, since this N1 is going back to Q, so it put only one flip-flop. Do you understand the difference? Since after this line, this one will happen. So at the end, you need actually only the Q. Understand? That's why it removed this part. It removed this part, only kept
Here, before finish.
yes,
this
before
one.
this finish, this one also
Second.
executes. So you need two of them, two operations same time. Here only at the end you need Q. So he made a D flip-flop with output Q, input is D. Okay, because this is serial, first line, second line. But this one you need same time. So to do same time you need two flip-flop. Do you understand? But it is as if one flip-flop. Okay. So this is the summary. So another thing is this third category assign. This is we use if we design simple combinational circuit, not sequential. If you use simple combinational circuit, you will use assign Y gets B this way, and these two we use inside always. This you should note. These two assignment we always do inside this always statement. But the third category, assign Y gets A and B like this, these are written outside always. Outside always. Okay. Now the last topic we will see from this chapter 4. In chapter 4 there are other topics. Okay. The chapter is big. There are other topics. Some of them are optional. Some of them are outside our scope. Okay. So when you study chapter 4, you should study those topics we covered in the class. You understand? In chapter 4, if you look at the book, chapter 4, there are other examples, other topics of like designing finite state machine, designing counters, other things. Okay, but we did not cover it. So when you study for exam, you use the slides to read only those topics. Is it clear? Okay. So the last thing we will see is called parameterized modules. Parameterized modules means remember in this marks, yes, remember this marks
Yes.
we designed using ternary operators.
Yeah.
So how many inputs? 2 inputs, right?
Yes.
Each of them 4 bits. Output is also 4 bits. Now, if S is 0,
D0 go.
D0 will go to the output. If S is 1, you get D1 to the output. Right. Very good. Now, say I want to use 6 bits or 8 bits or 12 bits. What should I do?
12.
Say here how many bits? 4 bits, right?
Yes.
Now I want to have a marks with 8 bits input.
7. 7.
So I should change here 7, right?
Yes.
Yeah.
That will make it 8 bits.
Yes.
Right?
We can another.
And another way we saw use
Yes.
use two of them to make 8. We saw this one.
Yes. Yes.
Okay.
Yes.
So
From 0 to 3 and.
yes, this
4
one
to 7.
marks will take from 0 to 3.
And 4
Another
to
one
7.
4 to 7. Yes, this is another way we saw. Now, in parameterized module, actually what you can tell is, you can tell that this size can change. Do you understand? It is like, what can I tell you? Like, for example, say when you order, it will give you more or less. The same thing, the same packet, but you can select the size. Okay. It is like same package, but you can select which size you want. You understand? Like tailoring. Same cloth, but you can have big size, small size, right? When you go to the shop, the same cloth, same design, everything same. You have different size, right?
Yes.
Different size. Based on yours, whatever you need, you take the correct size. So here, your input is how many bits? 4 bits.
Oh.
Now we want to. It is good that if I have a marks, like say a box, and I will tell him how many bits I need. Do you understand? I will tell him how many bits I need, and it will give me a marks with that size.
Not everything.
No, I don't want to change every time. Do you understand? For 8 bit I need to make it 8. For 16 bit I need to make it 16. No, I will write only one code. Do you understand? Only one code. But every time I will tell him how many bits I need, and it will give me that number of bits. Do you understand the difference?
Okay. We have 1 marks, it's per bit, or 1 marks we can do a fan.
Yes, it's like infinite. You can say theoretically not infinite, but you can say change. You can change. So how you can do is, let's see that it is very powerful. Yeah. See, again the name is same. Okay. Module marks 2, same name, no problem. You can give it different names. This line is extra. Okay. This line is extra. See, here you are saying a hash.
Yes.
A hash in the bracket parameter width equals 8.
Why?
This parameter is a word you need to put, fixed word, okay? And this is, you can give a name, anything name. My width, your width, like a name here, huh? Equals 8. This means this mask, if you do not tell anything, input will be 8 bits. Do you understand? If you do not tell anything, like if you go to the tailor if you do not tell anything, he will make a default size, right? Default size, like your column. Say, if you don't tell anything, it will make, say, 2 inch. Suppose default. So this is, if you do not tell anything, the mask that you will get is 8 bits. But if you need 4 bits, if you need 2 bits, if you need 12 bits, you can change it. You can tell it and it will make a 12 bits.
Just change 8 and write
No,
12.
no, not here. When you make an instance, then you tell. Okay, we'll see.
In the third. 0, 0. It's a 1 bit.
0, 0?
1 bit.
0, 0. It depends. It depends how you implement. As a number, it is 1 bit. 0 is 0. You need 1 bit.
Yes.
But if you think that you have 2 wires, giving 0 in one wire, 0 in another wire, then it is 2 bits. So it depends actually how you are using it. You understand? Like if you have 8 lines, if you put like 4 lines, so if you put all 0, the number is 0, which is same as 1 bit 0. But it has 4 lines. Do you understand? 4 lines. So here the values are not number. Actually, these values are not number. These values are signals coming. You need to understand this. You understand? 0, 0, 0, 0 in our examples means you have 4 wires, 4 lines coming, not a number with value 0. Do you understand?
Yes, yes.
Yes, this is 0, all 0. But 4, 0 means you have 4 lines, each line is 0. Do you understand? It is not like C or other programming that 4, 0 means a value 0. No, you need to think about hardware. That 4, 0 means you have 4 wires, each of them
1 bit.
is 1 bit and each of them value is 0. Okay. So, and other part is same, exactly same. The only thing is here you write, before we wrote this thing, right? Right? For 4 bits, we write like this, huh? Here, now you make it like variable. You make it, say width minus 1. Width minus 1. Meaning here default value is 8.
Simple range.
8. So this one means 0 to
7.
7. Default, by default. It means 0 to 7. So if you do not tell anything, this code will produce a mux. Each input is 8 bits. Each input is 8 bits because here the size is 0 to width minus 1 and default value of width is 8. So D0 and D1 will be 8 bits.
0
Mm,
If I
0
put,
to
if I put 0 and 2, that's minus 2. That's
0 to 2 here,
yes, yes.
3 bits, it will be 3 bits. But not here. We will, if you want to change, we will change different, not here. Okay. So, and this line is same as your marks. Huh? Now, if you want to create an instance with 8-bit bus width, 8-bit, this D0, D1, we need 8 bits. Then you just call marks2 and give a name and send your parameters, not parameters, send your inputs and output values. Output values. So this way it will create this mux1 where this D0, D1 all are 8 bits. All are 8 bits. This is also 8 bits. 8 bits. But if you create an instance in this line, this one means it will create these marks where these inputs and outputs are 12 bits.
Output why 8 bit?
Because here we have a marks D0,
Yes.
D1, Y. So this is 8 bits, this is 8 bit. So output should be 8 bits. Okay. And here before you write the name, you put this part hash in the bracket a number. This one means
What? Wait.
here. Yes, the width. Yes, the width. This number here means, this one means it will create a marks. This is S. This is D0, D1, Y. But here the size is
From 0 to
12. Size is 12. Yes, from 0 to 11.
11.
Do you understand? It is like when you create the marks, you tell how many bits you need. Do you understand?
How many?
How many bits here?
How many bit here?
How many
Right
bits
here.
for D0, for D1, and for Y? Because you define it here. See? It is like you are giving the value of width. It is like your tailor. It is like a tailor. He has some default values, right? Like in the last class, I talked about these buttons in your class.
Yes.
In your class, right? It's white color, red color, right? He has some default. But if you want to change, you have to tell. Do you understand? This is called parameterized. He has some default values. Like he will make this one this way, this one this way, this one this way. But if you want to change, you need to tell. Do you understand? Same thing. Default is 8 bits.
8 limit.
Yes, 8 bits. Default is this one. Default is this. Okay. But if you need to make 12 bits, you need to
6.
call or make instance like this. Before you make an instance here, you put this part hash in the bracket 12. It will create a marks with 12 bits. But if you want say 16 bits, you write here 16. Then it will be 16, this will be 16, this will be 16. Is it clear? Okay. So this is the end of chapter 4.